Hello! In this video, we present the first synthesis of levetiracetam, according to the retrosynthesis outlined in the previous video. In general terms, the synthesis employs in the key step an asymmetric alpha hydroxylation to the aldehyde group of butyraldehyde to prepare the substituted 1,2-butanediol, which will incorporate the 2-pyrrolidone in its carbon 2, and, continuing with functional group transformations, will generate the final product. Butyraldehyde, when reacting with the amino acid, L-proline forms enamine 2 and in the presence of nitrosobenzene 3, through interaction with the carboxylic acid of proline, forms intermediate 4, where nitrosobenzene is in the alpha orientation. Next, the nitrogen. From the heterocycle, it attacks the nitrogen of the nitroso group, forming intermediate 5. Compound 5, through a 2,3 sigma tropic rearrangement, gives rise to intermediate 6, where a carbon-oxygen bond with alpha orientation has been formed. The abstraction of a proton generates intermediate 7, and, when adding to the reaction medium, sodium borohydride in methanol forms the monoprotected diol 8 with a high enantiomeric excess. The overall result of these transformations has been the asymmetric aminoxidation of butyraldehyde and the reduction of the aldehyde to the primary alcohol present in 8. The breaking of the oxygen-nitrogen bond is achieved through catalytic hydrogenation to generate the secondary alcohol with R configuration. The regioselective protection of the primary alcohol in 9 is achieved by treatment with the tin reagent shown here to form derivative 10, the heterocycle 10 by reacting it with benzyl bromide in the presence of phase transfer catalysts. It opens up producing intermediate 11, which ultimately yields the monoprotected diol as benzyl ether 12. The secondary alcohol in 12 is converted into a good leaving group by forming its mesylate to create compound 13. The nucleophilic substitution of the methyloxy group by the 2-pyrrolidone 14 occurs with inversion of configuration and produces the intermediate 15. The catalytic hydrogenation of the benzyl ether produces primary alcohol 17, which is oxidized using tempo and sodium chlorite to generate the carboxylic acid 18. Finally, carboxylic acid 18 is converted into mixed anhydride 19 by treatment with ethyl chloroformate. And without isolating, ammonium hydroxide is added to the reaction medium to prepare the final product with 75% yield and 99.5% enantiomeric excess. In summary, here are the raw materials that contribute to the structure of the final product. Thank you for your attention.